Welcome to the debate. When you build a backend in Python, it's like a physical bank vault. You present the wrong key, the gears lock up, the alarms sound, and the entire system just strictly stops.
Right. It fails loudly and, securely.
Exactly. But then you transition to the web. You look at JavaScript, and you are definitely not in a vault anymore. It's more like a crowded, noisy casino.
A casino? Okay.
Yeah, the rules bend depending on the game, chips change hands invisibly, and if someone drops a token, the game just keeps going as if nothing happened.
Well, sure, because you're dealing with a completely different physics engine, essentially. The web literally cannot afford to lock up every time someone drops a token.
Which brings us to the core tension we're looking at today. Is JavaScript's design, its asynchronous nature, its aggressive type coercion, its client-side execution, inherently more dangerous and prone to logic flaws than Python?
Or does the danger only happen when developers incorrectly map their Python mental models onto a fundamentally different web architecture, which is what I argue?
Right, and I'm taking the stance that Python's strict, predictable execution is just inherently safer, whereas JavaScript semantics actively invite security vulnerabilities. It's like Python, but worse.
That's just that classic collision of expectations versus environmental reality. People want JavaScript to act like Python, but it's designed to do something else entirely.
But that something else creates massive vulnerabilities. Look at how these two handle exceptions. Python actually forces you to acknowledge a failure. If an operation fails, the script stops. But in JavaScript, errors are just constantly swallowed. Take a simple JSON parsing failure, for instance.
Okay.
If a developer leaves an empty catch block, the program just keeps moving. There's no log, no alert. You're left with a corrupted state where you can't distinguish a legitimate user from malicious input.
Okay, wait, but an empty catch block is a developer logic error. You can't blame the V8 engine for doing exactly what the developer told it to do, which is absolutely nothing.
Sure, but the language's philosophy actively encourages it. It's like you hired a bouncer for your club, right?
Right.
And when someone hands him a library card instead of an ID, he just shrugs and lets them in anyway. And he completely forgets to write it down. Python, on the other hand, stops the music and turns on the house lights.
Well, yeah, because Python can stop the music. It's a synchronous blocking process running on a server. JavaScript is an event-driven, single-threaded language running in a user's browser.
Which is exactly why it's so fragile.
No, its underlying philosophy is about keeping the UI alive. You simply cannot have the entire browser freeze up and crash for the user just because a minor network request failed or, a piece of JSON was malformed.
Even if keeping the UI alive is the goal, the way it manages state after that failure is a nightmare for secure access control.
How so?
Because even if you do log the error, the application state is often already corrupted by how JavaScript handles memory and types under the hood.
Corrupted how, though? Give me an example.
Through its sheer unpredictability. If I evaluate, the string 5 plus 1 in JavaScript, I get the string 5-1.
Right. String concatenation.
But if I evaluate the string 5 minus 1, implicit coercion kicks in, and the result is the number 4. You're trying to build secure validation logic on a foundation that constantly shapeshifts.
Okay, but...
And don't even get me started on variable hoisting with var. You can have a role variable that exists in memory as undefined, even if the if block that was supposed to declare it never actually ran. The code doesn't break, it just behaves strangely and bypasses your logic entirely.
Okay, hold on. You're pointing to legacy behaviors that the language has actively solved. Modern JavaScript gives us let and const for block scoping exactly to fix that hoisting issue.
Yes, if developers actually use them.
Well, they should. If you use let, it strictly respects the curly braces. If you try to access it outside, you get a reference error. The program crashes exactly like you want it to.
But that relies on developers opting into the safer syntax. The dangerous path is still the default fallback for millions of lines of code out there.
Sure. Bad code exists. And on the coercion front, V8 isn't doing this just to be chaotic. It's forcing a best guess to avoid crashing the user experience.
A best guess in security is a terrible idea.
But you don't need a perfectly strict type match if you just understand how the engine evaluates truthy and falsy contexts. Things like 0, empty strings, null, and defined, they're falsy. If developers just have precision in their Boolean logic, coercion isn't unpredictable at all. It follows a very strictly defined set of rules.
I will concede the rules are defined, but they are incredibly unintuitive for anyone coming from a strictly typed background. When a developer assumes exactness and the engine prioritizes a best guess, you get logic flaws.
Well, that's a mental model problem, not a language problem.
But frankly, even if a developer masters let and perfectly predicts every coercion, the syntax is only half the battle. The real issue is where this code actually lives.
You mean the browser environment itself?
Yes. Relying on JavaScript for security is ultimately futile because it executes entirely inside the user's environment. Think about a standard client-side login demo.
Right, the classic example.
A developer writes a check access function to parse a user's role. But an attacker doesn't even need to touch the UI. They can just open Chrome DevTools, go to the console, and rewrite check access to always return true.
Oh, absolutely.
Or they just programmatically inject the admin role, right? The application trusts the logic, but the attacker owns the execution environment entirely.
You are absolutely right about the vulnerability, but you're blaming the wrong part of the stack. I mean, you just proved exactly why the input field was never a real security boundary to begin with.
Because the client can always be manipulated.
Exactly. The architectural reality of the web is that HTTP is a stateless request response model over TCP/IP. JavaScript's job in the browser is to manipulate the DOM and coordinate with the rendering engine. That's it.
So you're saying we shouldn't expect it to do more than that?
Right. Expecting it to enforce authorization is an architectural failure, not a JavaScript failure. The true security boundary is on the server, responding to GET and POST requests. If an attacker rewrites a function in DevTools, the server shouldn't care because it should never trust the client in the first place.
So the danger really surfaces when developers treat the UI as a gatekeeper rather than just like a traffic manager.
Exactly.
Client-side JavaScript can always be observed, it can be modified, and bypassed. It simply cannot independently enforce trust.
Right, which highlights why we have to understand the whole web architecture, from the V8 engine all the way up to the HTTP networking layer. You can't just compare Python and JavaScript syntax in a vacuum. True security lives on the server.
Which makes analyzing these structural differences the absolute cornerstone of secure software engineering. And it leaves us with, well, a lingering question. If the vault is on the server, but we spend all our time designing the casino on the client, who bears the ultimate responsibility when the chips are stolen? Is it the architect of the casino or the rules of the game itself?
Well, that is definitely a question worth exploring further in the material.
Indeed. Thank you for joining us on The Debate.